Hello everyone, very good day. Today we are going to look into load balancer, which is the most common component in a system design. We will look into more details in the upcoming slides. So what is load balancing? So in a real-time world, consider any distributed system. So there are millions of requests which will be arriving at a second. So to serve these requests and none of the requests or go unnoticed or have interrupted services, load balancer helps us to route these millions of requests to the respective servers by balancing the load with there are list of defined algorithms, and it manages the load and distributes the request to all the application servers or a web servers. Load balancer is a answer to a question if all the requests are distributed among the common pool of service. So any distributed system load balancer is inevitable in the system design. We need to have a load balancer. Either we can have at the global level or we can have at the local level. Why do we need a load balancer? Load balancer is a first point of contact. Once a request comes through the firewall, it reaches the load balancer. What load balancer provides? Load balancer provides scalability. We can add n number of nodes and place the load balancer as a front layer before the application service. Load balancer acts as a reverse proxy. A reverse proxy in general is a server that sits between before the actual server, and it acts as between the client and the server, and it sits before the server. So load balancer acts as a reverse proxy. What it provides? Scalability and availability. So at any point of time, even when the nodes goes down or the number of requests increases, so the client will get the response. If the node goes down, it will route to the other nodes until the node comes back. In that way, we achieve high availability and performance. Load balancer can forward the request to the service with a lesser load so that the user can get the quicker response. So this improves the performance. It is called performance based routing. The nodes which a lesser node will always get the next request. Let's look into a simplified load balancer, how it looks like. Suppose we have n number of users, user 1, 2, and goes till user n. There is a load balancer. The request goes to the load balancer, and the load balancer distributes accordingly using, it could be any algorithm like hash algorithm or round robin or performance based or weight based. So it routes the request to the pool of servers accordingly. How a load balancer distribute the request among the pool of servers? That these are the following algorithms. Round robin. So consider there is a server 1, 2, 5. So the first request goes to server 1, and the second request goes to server 2, on and on until 5. After 5, again a new request comes in, it will goes to server 1. Weighted round robin. So what is weighted round robin? Each node will be assigned a weight. Consider an integer. Suppose if node 3 has a higher weight, when the first request comes in, it goes to the server 3. And least response time. Least response time is the one out of these 5 servers. Consider server number 4 returns the response in a quick turnaround time. It has low latency basically. So in that sense, so the server with the low response time will always get the request. Least connections. So it distributes among the connections. So when distributing the request among the servers, so it checks whichever has received the least connections will be routed to the request will be routed to that servers. We will look into load balancer in a 3-tier architecture. This is a 3-tier architecture where we have load balancer placed in between client and the web server, and we have placed a load balancer between web server and the application server, and we have placed a load balancer between the application server and the database. So when a client sends a request, this load balancer distributes the request to the web servers, and the web servers before reaching the application server, a load balancer takes care of routing it to the appropriate application server, and of course application server has to connect to database to read the data, or either to update the data, or delete the data. So the load balancer that sits before the databases server takes care of routing the request to the respective database servers. Now we will move into the concept of global and local load balance. So what is global server load balancing? Global server load balancing involves a distribution of traffic across multiple geographical locations. So what does it mean? So when a request comes in, we have a distributed system where we have data centers across the world. Suppose if a request comes from US region, the request has to be routed to the US servers. If the request comes from India servers, so India user, so the request should go to the India data centers. If the request in the India data center fails, it again reaches to the nearby data centers. Consider if a data center sits in Singapore. If a India data center is down, it routes to the nearest data center, which is Singapore. What is local load balancing? Local load balancing is the load balancer within the data center. Suppose consider there is a user request from Singapore and the data center in the Singapore through the global server load balancer receives the request, and then when it comes to the local data center, there sits a load balancer. That is local load balancer, which helps us to reach to the appropriate servers, and then the user gets back the response. So this is a classical example or a representation of a global load balancer. There is a number of incoming requests to the global load balancer. Then the global load balancer, with the identifying the region, it sends to the appropriate region, and each region has a load balancer as a front servers before it reaches to the actual servers. So the global load balancer routes the traffic accordingly to the region wise. Now we will look into stateful versus stateless load balancers. Stateful load balancer maintains the state of each request. So whatever the request comes into the load balancer, the state information is stored, and then the state information is used in the algorithm. Either it uses weighted, round robin, least connection, performance based. So it uses those algorithms to efficiently route between the servers. Now, so this is the example of stateful load balancer. So we have client sending the request to the load balancer, and we have other client sending the request to the load balancer, establishing a session. And the load balancer, using the session information, routes to the appropriate application server, and the application server gets back the details of the clients. Stateless load balancer, as the name denotes, there is no state maintained in the load balancer. So this is efficient when we use hash-based algorithm to route the request. So a stateless load balancer, of course, faster than stateful load balancer, and stateless load balancer is preferred if we go for hash-based routing of requests to the different servers. So this is when a client requests, a load balancer uses hash and then sends the request to each server, and each server serves it accordingly. Even though it comes in as a huge number of requests, it will be stored in the queue, and each request will be served by each servers one by one. So the concept is like at the global level. Suppose if there are multiple regions and the client in a particular region requests for a data which is available in region A, and the region A goes down, so it reaches to the nearest region B, and gets the data and sends the details back to the client through global service load balancer. Remember, global service load balancer should be the component mentioned if we design a system of a distributed system which spans across the globe or multiple regions, and each data center will have the local load balancer before reaching it to the appropriate application or a web service. Thank you for your patience in watching this video. Let us know in the comments like if you need to have any concept to be discussed in the comment section. And Intrinsic Intelligence is our YouTube channel. Please do follow for more such videos on system design concepts, algorithms. Thank you all.